Well, hello and welcome to the second part of Chapter 1. In Section 1.2, we are going to look at some more terms that you may or may not be familiar with. They are grade, which refers to the slant of a road mostly, or a physical feature. We're also going to talk about angle of elevation, the angle of depression, and then the relationship to distance. You'll definitely want to look in your textbook in this section to find the definitions that are going to go onto your definitions page for reference. Otherwise, we're going to go ahead and start some examples. And this first one is talking about the angle of elevation. If this person wants to put their quad onto their truck and the ramp is at a slope of 7 to 40, the question is, what is the angle of elevation? So the truck would be here, truck bed, and then the quad's going to go up the ramp. Sorry for my drawing, not very good. But we're looking for the measure of this angle right here. Sometimes the Greek letter theta is used to represent angles. And if the ratio is 7 to 40, that means it's 40 over and 7 up. To figure that out, we are going to have to use our geometry skills. If you remember the acronym SOHCAHTOA, we're going to use the TOA portion of that. In a right triangle, we have the hypotenuse, which is where the quad is going up. We know the values of the side that is opposite to the angle, which is 7, and the side that is adjacent to the angle, which is 40. So we're going to say that the tan of that angle is equal to 7 over 40. So to figure out the value of that angle, we're going to use our calculators and use our second function or shift button to figure that out. So you're going to type that in. Depending on your calculator, it will determine the order in which you type that in. And if you don't know or can't figure it out, make sure you ask someone who knows. In this case, when we type it in, we'll get an angle of 9.93 degrees. Make sure your calculator is in the correct mode. If you're in radian mode instead of degree mode, you won't get the right answer either. So again, make sure you ask if you're not getting that right answer. And make sure you're practicing doing this even as you're listening right now. You can easily pause the video and do that. A similar question this time about a driveway. We're told that the angle of depression is going to be 1 degree. And that the reason you slant your driveway is so that water can run off it. So angle of elevation means looking up. Angle of depression means looking down. And we're talking about this angle right there as being 1 degree or more. The question in this case is if the end of the driveway is 8 meters from the house, so the end of the driveway is 8 meters from the house, how many centimeters does this driveway need to drop in order to maintain proper drainage? So this distance right here would be 8 meters. This distance right here is what we're looking for. I'll just put a question mark there. And we again have a right triangle. And we know that the angle that we're going to talk about is 1 degree. If that angle is 1 degree, we know an angle inside the triangle that also has to be 1 degree because we have parallel lines. The dashed line that I drew, which is called the horizontal, would be parallel to the horizontal that I highlighted in yellow at the bottom. So alternate interior angles of parallel lines are equals. So that angle would also be 1 degree. So relative to that angle of 1 degree, we're looking for the opposite side, which is the question mark, and we're given the hypotenuse. So when we look at the acronym SOHCAHTOA, we're looking for the trig ratio that has opposite and hypotenuse, which would be the sine ratio. So we would say that the sine of 1 degree equals the opposite side divided by the hypotenuse. So to solve this expression, I would multiply both sides by 8. On the right hand side, that cancels the 8 out, and that would allow us to determine x by typing in x equals 8 times sine of 1 degree. And when you do that, you're going to get 0.14, and that is measured in meters, which is approximately, if we move the decimal over 2 places, around 14 centimeters. Now this question said round your answer to 2 decimal places, so although in meters that would be correct, if I'm talking about centimeters, I would actually have to round to 13.96 if I look back in my calculator to what the more accurate answer would be. So that's just a detail of a question that you have to watch out for. Another example, this time involving grade. Josette wants to build a skateboard ramp with 20% grade. Now it's important for you to realize that doesn't mean that this angle is going to be 20 degrees. Grade is measured as a percentage, and the grade percentage is figured out in relative to the slope. So that equals 20. That equals the rise divided by the run times 100%. So in this case, we're told that the rise is 30 centimeters. Now we are looking for how long the ramp needs to be in order to get that answer. So we are looking for, I'm going to call this h. In order to find h, though, we're going to have to find x first using the grade because that represents the run. We would find the run, and then once we find the run, we can use that with Pythagoras' theorem to find the value of h. First thing I would do is divide both sides by this 100 to try and get the run by itself. So I end up with 20 over 100, which is 0.2 equals 30 over the run. So the question is 30 divided by what number is the run? So I would go 30 divided by 0.2, and I would get an answer of 150. So the run is 150 centimeters. So this x value is 150 centimeters. Once we know two sides of a right triangle, we can find the third by using Pythagoras' theorem, which says that 150 squared plus 30 squared has to equal h squared. So we'll type that into our calculator, 150 squared plus 30 squared, press equals, and you'll get 23,400 is equal to h squared. Now to get h by itself, we'll have to square root both sides. Looking back at the question, we're supposed to round to the nearest centimeter. So when I square root that, I'm going to get 152.97. So I'm going to round that to 153 centimeters as the final answer. I'd be curious what you think about the order of my work. Was it neat? Does it make sense the way it looks? If you were looking at this with new eyes and didn't see the order it was written down, is it super neat? I don't know if it is or not, but when you do your work, you want to make sure to keep your stuff organized so that I can easily see what you're doing. Sorry if I didn't do a good job modeling it on this situation. So there's your assignment on page 30 and 32. Again, make sure you're updating your definitions so you don't have to go back and do that later, and it's nice to have those handy. So that's the second lesson. All right, onward and upward, and I will see you next time.